Welcome to Cosmic Compass, where we journey together through the wonders of space and time. Out there, in the dark, hidden between the familiar worlds of Mars and Jupiter, lies a dwarf planet that has puzzled scientists for centuries. It was once nothing more than a fuzzy dot through telescopes, but today we know it holds bright, dazzling secrets that challenge everything we thought we knew about the asteroid belt. So let's travel with the Dawn spacecraft, retrace its path, and uncover what it revealed about Ceres, the icy, enigmatic world that refuses to stay silent. In 2015, as the Dawn spacecraft approached the dwarf planet, Ceres scientists around the world held their breath. Until then, even the most powerful space telescope we had, the Hubble, could only give us a blurry image of this mysterious world. What was waiting on the surface? Were there signs of activity water, or even something stranger? This mission was not just another survey. Dawn had already completed a 14-month study of the asteroid Vesta, and now it was about to become the first spacecraft in history to orbit two different extraterrestrial bodies. To do so, it relied on a technology that looked almost futuristic: ion propulsion. Unlike chemical rockets that roar to life with massive thrust, Dawn's ion engines whispered, pushing with the force equivalent to a sheet of paper resting on your hand. Yet they could keep running for years, gradually changing the spacecraft's speed by over 11 kilometers per second. With that, Dawn was ready to reveal the secrets of Ceres. The trip from Vesta to Ceres took nearly 2 years. During that time, anticipation only grew. After all, Ceres is the largest object in the asteroid belt, measuring almost 950 kilometers across, large enough to qualify as a dwarf planet. As we picture Dawn closing in, let's remember how remarkable this journey was. For decades, spacecraft missions were one-destination adventures. You launched, traveled, studied, and then the mission was over. Dawn changed that. With its 3 ion engines, it could gracefully leave one world behind and set its sights on another. You might ask, why was Ceres so important? Unlike rocky asteroids that are mostly metal and stone, Ceres had long hinted at something unusual. Its low density suggested it was not just rock, but also rich in water. And water, as we know, is the key ingredient for habitability, past or present. So when Dawn's cameras first began to resolve the fuzzy disk into a cratered world, scientists leaned closer to their screens. But almost immediately, something unexpected appeared. Strange bright spots gleaming like cosmic lighthouses from the surface. What were they? Reflections of ice, volcanic activity, or something else entirely? The mystery of these bright patches would soon capture global attention. As Dawn spiraled into orbit, each passing day sharpened the view of Ceres. Craters came into focus, ridges and shadows stretched across the dwarf planet's face, and the bright spots became undeniable. At first, they looked like a single glowing point. With better resolution, that one spot split into 2, then 3, then many. The community erupted in speculation. Some thought they might be exposed patches of ice freshly revealed by impacts. Others considered salts or minerals reflecting sunlight. A few let their imaginations run wild, whispering about artificial structures. After all, we had never seen anything like this on such a small world. But alongside the wonder, there was also a puzzle. Compared with the battered surface of Vesta, Ceres appeared to have fewer craters than expected. This suggested that its surface was not as static as an airless rock should be. Something was refreshing the landscape, erasing ancient scars over geological time. So what exactly was happening on Ceres? To answer that, we need to step back and look at what this dwarf planet is made of. Ceres is unlike most of its neighbours in the asteroid belt. While the majority of asteroids are composed almost entirely of rock and metal, Ceres resembles a hybrid between an asteroid and a comet. In other words, it is an icy world hiding beneath a dusty crust. On the surface, exposed ice would not last long, With Ceres sitting just 2.7 times farther from the Sun than Earth, surface ice would sublimate, turning directly into vapour. That means the visible crust is primarily rocky. But looks can be deceiving. The crust is porous with water locked within its pores, roughly 10% water to 90% rock. Beneath this crust lies something even more intriguing, a mantle of muddy, briny material. Think of it as a slushy ocean frozen in place, where rock fragments and salty water are intimately mixed. Deeper still, scientists believe there is a dense core of hydrated rock rich in clays. Some models suggest the mantle could hold even more water than we imagine, perhaps half of Ceres' entire volume. This abundance of water makes Ceres one of the most water-rich bodies in the inner solar system, and it's this hidden reservoir that may help explain the bright spots. Over time, pockets of salty water can migrate upward, reaching the surface and creating something extraordinary: cryovolcanoes. When we think of volcanoes, we usually picture red rivers of molten lava on Earth, or the massive eruptions of Ahuna Mons on Mars. Cryovolcanoes, however, are a very different breed. Instead of molten rock, they erupt salty water. On Ceres, these eruptions create the dazzling bright spots that caught our attention. The most famous of them lies inside a crater, where the largest patch, nicknamed Spot 5, sparkled like a beacon. Dawn's instruments detected a periodic haze above this region, a clear sign that water vapour was sublimating from the surface. Here's how it works. Salty water wells up from the subsurface and escapes through cracks. When it reaches the vacuum of space, the water instantly sublimates, leaving behind a crust of reflective salt. These deposits are fresh and strikingly bright, but over time exposure to sunlight and radiation darkens them, blending them back into the surface. That means what we see today are the youngest, most recent eruptions, active geology on a tiny world we once thought was inert. And the story does not end with a crater. Bright patches have been found in multiple craters across Ceres. Each one tells the same story. Water is still at work here, slowly reshaping the surface. Imagine that: an icy, distant world quietly breathing through its crust, revealing traces of a hidden salty ocean below. So next time you see those gleaming dots in an image of Ceres, remember, they are the fingerprints of cryovolcanoes, a reminder that even small forgotten worlds can be alive in ways we never expected. The surprises did not end with cryovolcanoes. Dawn also confirmed the existence of water ice in the permanently shadowed craters near Ceres' poles. Because Ceres has an axial tilt of only about 4 degrees, some crater floors never receive direct sunlight. These regions are like cosmic freezers, cold enough for ice to survive billions of years without sublimating. If this sounds familiar, it should. Our own moon has similar shadowed craters at its poles, where scientists believe ancient ice also lingers. This discovery makes Ceres even more compelling. Not only is water erupting in geologically recent times, but ancient ice deposits have also been preserved in the planet's darkest corners. Together, they paint a picture of a world where water is abundant, persistent, and dynamic. Ceres' surface is a fascinating record of impacts and geological stresses. Some craters are perfectly round and sharply defined, as if carved yesterday. Others are complex, with central peaks rising from their floors, a common feature on larger impact sites. In several places, Dawn spotted evidence of landslides, large blocks of rock that had detached from crater walls and tumbled downward, leaving trails behind them. These details remind us that even without an atmosphere or weather, gravity still sculpts the landscape. Beyond the craters, vast fractures crisscross Ceres. Some are grooves, where the crust has been stretched apart. Others form mountain ridges, where the crust has been compressed. Many of these features are surprisingly young, geologically speaking, perhaps only a few 100 million years old. One of the most striking images Dawn captured shows the limb of Ceres at an angle the horizon curving away into space. In such pictures, scale becomes tricky. Without an atmosphere for haze or perspective, mountains and valleys appear deceptively flat, but those shadows conceal features tens of kilometres wide and kilometres tall. Through these views, we begin to see Ceres, not as a static rock, but as a world shaped by forces deep below its surface. Among all of Ceres' features, none is stranger than Ahuna Mons. This solitary mountain rises about 5 kilometres high and 20 kilometres across. What makes it unusual is not just its size, but its isolation. There is nothing else like it on the entire dwarf planet. So how did it form? The leading theory is that Ahuna Mons is itself a cryovolcano born from internal stresses triggered by a massive impact on the opposite side of Ceres. Seismic waves from that impact would have converged at the antipode, the point directly opposite, and forced material upward in a dramatic eruption. Elsewhere in the solar system, we see similar antipodal effects. On Mercury, for example, strange chaotic terrain appears directly opposite its giant calorous basins. Ahuna Mons may be Ceres' version of that phenomenon, a monument to the hidden forces that ripple through planetary crusts. Standing alone on the surface, Ahuna Mons is like a geological oddity, a solitary witness to events billions of years ago. If there were ever a place on Ceres that embodies its mysteries, this mountain would be it. After more than a decade of groundbreaking exploration, Dawn's mission came to an end in 2017. The spacecraft had run out of the hydrazine propellant needed to keep its antennas pointed at Earth. Without it, communication was no longer possible, but Dawn was not abandoned. It was deliberately left in a stable orbit around Ceres, where it will remain for at least 20 years, perhaps centuries. In a way, it has become an artificial moon of the dwarf planet, silently circling the world it revealed to us. Its legacy is immense. Dawn proved the value of ion propulsion, showed us Vesta in detail, and transformed Ceres from a blurry dot into a living dynamic world. For future missions exploring the asteroid belt, Dawn has lit the path. So what did Dawn teach us about Ceres? That even the small overlooked bodies of the solar system can hold astonishing secrets. Beneath its rocky crust, Ceres hides vast stores of water. Across its surface, cryovolcanoes and fractures reveal that it is not frozen in time but alive with slow, subtle activity. As we look up at the night sky, it is easy to overlook the asteroid belt between Mars and Jupiter. Yet within, it lies a world that challenges our understanding of planets and their evolution. Ceres reminds us that the universe is full of surprises waiting for us to uncover. And who knows, one day, perhaps you might see a mission returning to Ceres, searching for even deeper truths beneath its icy skin. Ceres is a reminder that even small forgotten corners of the solar system can surprise us with beauty, mystery, and lessons about our cosmic origins. Thank you for watching Cosmic Compass. If you enjoyed this journey, consider subscribing so you don't miss our next adventure among the stars. Share your thoughts below. What do you think is still hidden beneath Ceres' surface? Until next time, let's keep exploring, keep questioning, and let the universe be our guide.